Welcome to our Expert Insight short presentation here in cooperation with VDMA Working Group Additive Manufacturing. Today we have the topic new application and new markets, and that is what we want for our product, new markets. And I have three interesting guys here on stage. They will show us about their applications and maybe their new markets. And we have here Thomas Batigne, he's CEO of Lynxter. Thomas, nice to have you here. Alexandre Schäfer, he's Business Development Manager of J.A.M.E.S GmbH. Good to have you here, Alexandre. Und Udo Burggraf, Sales Director EMEA of Additive Industries.
Thank you.
So they will give you the presentations, and I think we have not so much time. We have about 38 minutes here for the colleagues. And so let's start with the first presentation with Alexandre. Oh, no, with Thomas, sorry.
Thank you. All right. So, killer application is basically the thing to find in additive manufacturing. We've all heard about different kind of prototyping solution and some applications that do work at a scale. But at Lynxter, we spent the last 6 years developing a lot of different technologies, and one of them is actually game changer today in the industry. We're talking about silicone additive manufacturing. And by silicone additive manufacturing, I mean actual silicone. We're talking about two parts, medical grade and industrial grade silicones, that are printed with a material extrusion technology dedicated for this kind of materials. Interesting fact is we end up with isotropic properties, and also we end up with the final properties of injection molding with an additive manufacturing process, which is pretty interesting. So we dived into different applications with customers in order to find this killer application. And we found that silicone additive manufacturing can be game-changing in industry and in the medical field. The first one, in the medical industry, we're looking at epithesis, basically external prostheses for people to recover from an injury or from a cancer, printing direct silicone that is colored in the mass to print ears, noses, even parts of the bodies, for people who don't want to go through internal surgeries and internal implants. So thanks to the qualification of this silicone that is not put into question, going through this process, we can find a better way to solve custom issues at patients. Another one is for industrial applications. We've realized that there is so much time spent on taping parts, just basically to mask them and to go through a surface treatment process. It sounds trivial, but at the end of the day, we're talking about hours and hours of a repetitive process, which is very, very labor intensive and is not scalable. By printing custom devices like that are capable of masking some areas, some strategical areas in high-value parts, they can go through chemical treatment, they can go through heat treatment, painting, plasma, all of this kind of post-treatment, basically. Using actual silicones or polyurethanes for this matter, allow us to withstand a lot of different cycles and reuse these devices in order to, well, basically have a win-win situation with the customer. That was basically what we used to do last year, and then at Formnext we've released a new machine that's capable of printing supports. By doing that, we are now capable of printing basically any kind of geometries, even big overhangs, and we have the freedom of design that we could have in FDM, classic thermoplastic printing. So it is a mini revolution in our field, and we feel like all of our customers in the medical area, in the industrial area, will take the most out of this innovation to tackle new challenges.
So, well, that's very interesting. You know, silicon, to produce silicon additively was always was long time a problem. Just give me, maybe I did not get it correctly. What was the main obstacle, the main hurdle you had to take?
We're talking about thermostats. And when we talk about technical silicon, there is a technical issue, is that, well, silicon is liquid, and we want to peel up layers first. Second, we have to play with a lot of different parameters in order to not clog the mixer, which is mixing part A and part B. So all of that happened thanks to a lot of different partnerships with experts in the field. And now we're capable of making small parts, big parts, at a scale for a fraction of the cost.
And here is it.
So that's a very simple mask in this case. And basically, it's been through a sandblasting process, which is like very, very aggressive in terms of abrasion. And then it's been through a, it's powder paint, meaning that it goes into an oven at 200 degrees for a long cycle. And basically, everything they've tried was either polluting the paint, deactivating it, or was just not withstanding the condition, this harsh condition. It's like, fine, this part's been through the 200-degree process, and it's fine, it's reusable.
So why was it so important that you choose to handle silicone instead of choosing another different material?
Silicones are very technical material. They remain very soft, flexible. We're talking about pure silicones. They can withstand this temperature, which are pretty extreme when we're talking about thermoplastics or TPUs.
So did you make a research on different materials? Did you try to enhance maybe, or to put fillers, or to use some solvents or something like that?
Yeah, so our partners went through multiple PhDs to develop the right formulas, and we did the same to develop the machines. That's been a very, very long journey to find out what's the actual right formula and what are the actual right printing conditions, right? And now, a fun fact is that by allowing support structures, we are now capable of processing silicon that should not be 3D printed because they are not supposed to be extruded this way. But now we can have them in a kind of a dynamic molding process, and that's I think a game changer.
Okay, where can I put an eye on that here on Formnext?
So we're located at hall 11.1, just above. Basically, just at the left of the entrance. Yep.
Okay, and I can get a new ear at your booth.
Yes.
Okay, perfect.
Tonight we shoot a party.
A nicer one, actually, than mine. Okay, thank you very much, Thomas.
Thank you.
We are talking later, but now the stage is Alexandre's. He is, as I said, Business Development Manager of J.A.M.E.S, and we're very curious what you brought us.
Yes, so as you already know, the additive manufacturing is very well developed and experienced for years. And we have a lot of different materials, a lot of different printing processes, and cool applications. So when you have a look around, you see a lot of things there. But what is about electronics? So we have PCBs for decades, and from our point of view, it's time to change that. So what does it mean to come from an AM to an AME, so add the electronics into the additive manufacturing? What our goal is, we want to have real AME. What does it mean? I will explain it in a few seconds. So let's have a look on the AM itself. You can design your application regarding mechanical requirements, like with focus on weight or heat resistance. Then you can use the material, you can use the printing process, and then you can print your application, and that's fine. When you get some electrical requirements, then you have to do the step in between. So you get a small E on your AM. That means for antenna designs or thermal radiation solutions, for example. That means you take the 3D surface and print some conductive material on it, some wiring or whatever. We call it MID, Molded Interconnect Devices. In our world, from electronics perspective, we call it 2.5D, 2.5D. So because it's a step in between on the way to a real 3D structures. And what does it mean to have real 3D structures from our point of view? That means we have embedded components, we have 3D wiring, we have the same creativity, the same freedom like you will have in the AM itself. So currently, it's not possible. There are some challenges to do, or a lot, to come to this way. And we want to push this technology to the next level together. And that is why J.A.M.E.S exists. We created world's first online 3D community for AME, for printed electronics. And on this platform, we bring the whole ecosystem together because we have seen that the printer manufacturers are doing something, academia is doing a lot of research, we have enthusiasts, they work for years in that, and also the industry, they don't know about this technology or they don't know how they can use it or what is possible. And we bring all these stakeholders together. On this platform also what we are doing is we share our knowledge. We want to educate the people. We want to show how does it work, what is possible. We have a lot of applications and examples there to copy it, to have an easy access to this technology and to have some synergies between all of us to push this to the next level and to come to real AME. This is what we want to have. And if you want to see some applications about it, please visit us, come to our booth, and we can have a small chat. I can show you something, what is possible today, and how does it work. So I'm looking forward to seeing you there. Thank you.
Yeah, Alexander, thank you very much. So we know now where to go, but I wanted to dive a little bit deeper into what we see there and how it actually works and what were the obstacles you have to solve on the way. I learned some years ago that it was a really problem just to print copper. So
yes,
to have the copper printing process was really a problem in the first beginning. And you're trying to print hybrid materials.
Yeah.
So what were really the steps? Please explain to solve these problems.
Yes. So when you have a look on the whole process, so to come from an idea over digital design to a real print, the first thing is we have to change the mindset of the people. So this is one of our biggest challenges, let me say.
When you're talking about people, you mean
the engineers, the designers,
the end users, or
not the end users, the designers. They design or develop the applications.
In the first step, the designers.
Yes, because they are in the PCB world and they think in layers and vias and in 2D structures. And to bring them to think out of the box into real 3D structures, this is the first.
You're talking about the people engineering the circuits, the circuit designer.
Yeah.
Okay.
Yeah. And then when you have when you are lucky and you convinced someone to think from PCB into real 3D structures, the next question is, which tool can I use? And that is the
for
next
designing. Which designing?
For designing, genau, yes. And this is currently the next problem we have to solve because there are some E-CAD tools for electrical design, some M-CAD tools for the mechanical and 3D design, and we have to merge it manually currently. So, and this, is not the best process. And we also cooperate with software companies. They design such tools to tell them, hey, we need something. The best thing will be a 3D auto router, let me say so. This will be the best way to come from design into real 3D structures.
Okay, and once we have the good designed product, the additively producible designed product, what is the next step? I'm curious about the machining. How do you do that?
Yeah, we have some processes available also in this world. From my point of view, the most developed process is the inkjet process, where you have a DI, a dielectrical material, and a CI. In this case, it's silver. And then you can print layer by layer or dot by dot, and you can design a conductive or non-conductive layout. Then you can use pick and place to add some components on it.
Ah, okay.
And what we also want to have is another process is called micro dispensing, and then we want to replace the wire bonding for the components so that we connect the components via micro dispensing into the whole system, and then print again to put it to encapsulate it into the whole system and in the whole design. So currently we have this process. We begin to print, then take it out, pick and place, micro dispensing, back again to the inkjet process, and then print again. So.
And if you're ready with that product, is there another post-processing steps, like in other processes where you have the supporting structures or something? Then but when you are finished, then you have the product you can put into a computer or
there's no. Currently, we are talking about such sizes like that in this electronics area, and so we don't have to do any other step behind. Yeah.
But all what you said, I believe everything you said, but it sounds very cost intensive. We had a discussion this morning with Mr. Hering from VDMA, and he brought with us some results from a survey.
Okay.
And the main issue there was cost.
Yes. So to be honest, this technology is currently on a technical readiness level between 4 and 6, let me say, around that. So prototyping a bit behind. And it's a long way to mass or serious production. That's the reason why we also want to have all the people on one table to discuss this. And that's true. Currently, the prices, it's expensive to do this and give for
it's
that.
Still a challenge.
Yeah.
And look into the future. Then the goal would be someday to have one machine process which combines all the steps you said in a one hybrid machine.
Yes, that would be very good. So merge of materials also to get some materials from the AM. We need it also into electronics, and to merge the different processes into one solution. That would be the dream, let me say so.
So everybody who can fulfill this dream here at exhibition or at home in our stream, here's the right person to talk to and to make dreams come true. Thank you very much, Alexandre.
Thank you.
We can talk after our third presentation a bit more and dive maybe a bit more if we have the time. I don't know. It's exhibition is always a very time-consuming business. But now we have Udo Burggraf, Sales Director EMEA of Additive Industries. Udo, come here with me and show us what you brought with us.
Yeah, thank you very much. So I brought with me today a use case I would like to share about a established technology, laser bed or powder bed fusion, an established application which is an impeller for a pump, but a technology and a setting right now that opens up new opportunities in new regional markets, like, for example, EMEA, Eastern Europe, and Africa, especially in oil exporting countries. So we're talking about a use case we did with our partners. It was a joint effort with Equinor, which is an international energy company, Eureka Pump as an OEM for pumps, K3D, which is a service bureau in Netherlands, and Additive Industries as the OEM for these machines. On the right side, you can see an oil rig that is Stratford A, which was once one of the largest platforms in the Northern Sea. So we're talking about ballast pumps. A ballast pump is crucial for the trim of vessels and platforms, and it actually pumps water, seawater, into a ballast tank and out of a ballast tank. And the specification here in this special case was that this ballast pump is in operation for quite some time. It had a duty point at about 1,000 cubic meters an hour. And now, at the tail end production of this oil rig, the operator induced actually and started a re-rating of the pump so it can be operated at a duty point of about 50 cubic meters an hour, a significant change. So if you are in that situation, you have three possibilities and three options how to proceed. First one is actually use this pump and add a choke valve to reduce the flow and the power, the output power of the pump. You can buy a new pump, which is a large investment, but brings to the lowest operating costs. And you can modify the pump by replacing the old impeller by a newly designed one. On the right side, you can see what happens. The red curve is the working curve of the old pump. If I would reduce the flow, I would end up with a pump creating excess pressure and excess energy, and it would on top actually operate a pump outside of the design point. So the efficiency, the rate between input power and output power would decrease significantly, and I would have to invest a lot of energy actually to operate the pump in this off-design point. So we used here actually the full process chain. We started, or Eureka started, with a 2D drawing. We made it a 3D model. We did simulation with CFD, validated if the new design works as expected, printed the part, did the machining, the certification, and the installation. So there are standards out there in the meantime, like the DNV GL STVs 203, that gives us actually recommendation how to do the full process chain and how to certify those kind of parts. And you can see that we have a work split here between an OEM who does the design and the certification and the service bureau right now that does the manufacturing, the printing part. And this is actually significant if you want to go to new markets like oil exporting countries in Africa, where the IP still sits with the OEM, who's located somewhere here in this case in Norway, and then a service bureau that is closer, let me say, to the place, location where we are producing oil and energy and gas. This, the printing process was done on a metal fab, to see at K3D in the Netherlands. You can see the part, how it comes out of the machine and the finished part nearby. If you want to learn more about additive industries and our machinery equipment, come by the booth D11 here in this hall. You can see also now the old impeller and the new one, the installation and putting the pump back in operation. And what quite interesting fact actually here is that we had cost savings on two levels. First of all, the operator had to buy less carbon dioxide certificates, which gave him a cost saving of about 174,000 euros a year. And on top, of course, a lower energy bill, which added another saving of 236,000 euros. In the end, he ended up with cost savings of 450,000 euros round about per anno per pump. So we can see additive has reached a state right now where you can have significant cost savings using additive manufacturing. This impeller could have not been manufactured otherwise, and it could have not been manufactured in that lead time. This whole process took Eureka and K3D about 8 weeks from the design to the installation at Stratford A. Thank you very much for your attention.
Yeah, thank you very much, Udo. Very impressive. You picked out a very nice example because that is an industry sector where they have really time pressure, and every minute a pump is not working, they have they are losing a lot of money in the oil and gas sector. That's very, very impressive. Maybe just I'm not sure if I understood it right. So maybe I'm the only one here, but please explain to me again. You said he needed a lot less certifications while using the 3D printed part. I did not get that point quite clearly.
It's not less certification. We see that we now have established standards in the industry how to certify an AM part.
Okay.
In this special case, the solution was made that this part was treated actually as a spare part and not a new design, which simplified certification significantly.
So if he would have bought a new pump in the total, so he would have a lot more of certification work because he had. Okay, I understand.
Precisely. Now it's treated as a spare part with less effort.
And that is the case for just the oil and gas industry, or can you please compare to, I don't know, medicine, where you have a lot of certification issues as well, or flight industry?
No, standards are different in different industry. So this applies here with this standard in this industry, these kind of applications. So I want to point out again.
Just, I'm here at the stool, sorry.
Okay, sure, sorry for that. So I just want to point out again, we have now a setting where we have an OEM who has the IP and does the certification. But we are producing the part in a totally different place. And we can do it now also in new markets. So we're setting up a service provider, for example, in Nigeria, who can support the oil and gas energy industry locally. So we can overcome the situation that we have to export parts. The companies have challenges actually to get parts into this country because of local regulations at the borders. Now we're transferring only data, and the parts can be produced locally. And this example actually sets the pace here and demonstrates it is possible now. We dreamt about that quite a while ago, and now you can see here we are a step further. The machines are mature enough, the processes and the standards are there, and we can take now the next steps to go into new regional markets and where there's less expertise in AM right now because we have reached that maturity in the application and in the process.
Well, let me talk about the material you're using, because the pump is again a very good example, because you cannot use any metal as a pump impeller. So you need the expertise for each of these products. You have you produce a spare part. Yeah. How do you manage that? I think that's a very huge problem to keep that on track.
It actually isn't such a problem. So here in this case we use stainless steel, which is a well-known material. But with this setting, all this know-how and this IP stays with the OEM of that part, here in this case with Eureka. They know their materials, they know their certification processes, but they can, let me say, subcontract now the realization and printing of a part to another company that doesn't have the expertise. So they have only to share, let me say, a subset of their IP with a service bureau to get that part printed locally, and all the IP remains with the OEM on materials, certification, and design.
And is it common that they transfer a sort of something like a running guarantee or stand-up time guarantee with their choose materials for that part?
Yeah, absolutely. So these are materials, they are familiar with the materials, they have their established tests, which are the same actually for, or similar for AM with other...
So the end user can feel safe,
absolutely.
So they get a guarantee about that.
Absolutely, that's right.
When you're talking about, or give us some insights, please, about the different steps you said. So you have the certification we talked about, but the service is always a topic, and the producing of the part, and the discussions with the customer, which part is really needed. What are the most time-consuming steps for you, and where can be an improvement in your opinion?
Now we have an established process here right now. All that, talking about service,
so everything is fine for
customer.
You. So you are really happy?
Not fine. But it stays with the OEM, who does it anyway, independently of the manufacturing method. So this is the same, the service and all the kind of discussion. But right now we can split, let me say, the production in AM, the production from all the service activities, which still remain with the experienced OEM, which is a core part of his activities. There is nothing new here on this side, on the service side, and on the material side. But we can do it right now with AM, and we can decentralize these activities.
Okay, my hope was that you say something like, we need a digitalized process, that somebody at the oil and gas station, he just types in which part he needs, and on the other side of the world, something pops out of a 3D printer, something like that, I hope.
I think you invite me, let me say, in 5 or 10 years again, and then we can talk about that. That's very much in the future. I think it's all what we dream about. But we have to do baby steps right now. We dreamt about this idea a couple of years ago. It was not possible, actually, because the expertise was not there, the technology was not mature enough. We are at that point, so we are making right now the next step is a decentralized manufacturing. And then, of course, if you are about data, next step would be how can I secure my IP? Because I give away, of course, the design and the build file to another company outside, let me say, of my region. That's the next step where we have already software solution in the making. And if this one
there are some signatures which are built into the part so that you can identify it.
And also, of course, on the job file itself to make sure that it's only used for this specific production of that specific spare part. So that's going to be the next step. And if you have that done, we will more and more digitalize the whole process. Keep in mind, when we started, there was a 2D drawing of that pump, so it has to be digitalized for the very first step. But doing that over and over again, our OEMs actually have a more and more digital inventory that allows us actually then, in the next step, to look at this direction.
Okay.
Baby steps, one of the other.
Yeah. One question concerning the signatures. There are some thoughts about choosing a blockchain technology to identify it. Are you familiar with these kind of talkings as well?
At the moment, I think we're missing a standardization. There are many technologies here and many offerings. Basically, it's a decision of the OEM. Just imagine that you have in a platform many systems, many different OEMs, and at the moment it's not a given standard that we use exactly this technology for all systems and over all
It's similar, like the topic in connectivity. We are talking there about OPC UA or something to get a common language, and we should need that on that side as well.
Yeah, we need these standards.
Okay. Who would be the best to work on these standards? Is it VDMA, like a group of manufacturers, or is it a broader?
Let me say, the companies who offer the solutions, of course, they will always propagate their own solutions.
So they have...
Basically, I think it's
there is a competition on the one side, but we need a standardization.
Yeah, and I think it's the OEMs, basically, that have to drive and set the standards so that the industry and the supply chain actually then follows their lead.
Okay, thank you very much, Udo.
Welcome.
I have some questions for you guys as well. I don't leave you so early here from my stage. I want to have a question for all three of you, but I'm more interested in you both because your answer is, I think, quite clear, or it was quite clear. I want to know how would be a next step to to transfer what you have learned in your process to another industry sector or to another production sector. Do you have ideas, or is it just out of sight?
No, definitely. What we've realized that, I mean, no one actually want to buy a 3D printer. They want to make parts, right? It just happened to be the right technology to do that, and we have to work on the software side and to connect with what you were mentioning about digital warehouse and all of that. We're talking about job-specific software to design easily the parts. When we were talking about masking application before, when you think about it, we're talking about a workshop with very manual work to be done, and the printer is here to make the part directly, and basically you just have to give a couple of specifications and you get your part, if it's a simple part. So to spread the technology to other sectors, we have to work on turnkey solution to allow the Lambda user who just want part to be able to get these parts either through a service or by internalizing the technology. So UX has to improve a lot, and the software suite has to be developed like way more than what it is today. And I think that's a big challenge for all of us here, is to get something that everyone can actually use. And 3D printing becomes a thing in the backstage somehow. Even if I'm an OEM and I like these machines, but I think that's what we have to do for the customers.
Alexandre, what would be your transfer to another industry sector from what you're doing today, and where would you say, okay, the one or the other guy here at the exhibition, they should come to our booth, and then we can talk about the future, and maybe we can transfer the one or the other what we learned, not to use it in electronics, but in another industry sector.
This is a good question, but currently we are in the area of electronics. We try to learn from the AM more and more.
But my question was the other way around.
Sure. Yes, that's true. But we have a lot of things to do currently in this process. We have a lot of challenges there, and yeah, I think what we have seen is of the current status of technology. What we can do is antenna design, high frequency applications will be a first step where what we can use to design applications and to use this technology now. This is what we see, and this high frequency applications are in different areas like defense or sensoric or whatever. So that's, from my point of view, a good point to start with this technology there.
But you know what I wanted to get when I asked this question? I wanted to get you connected, guys. I wanted that you come out of your box and go out in the halls and have not only your processes and your products in mind, make a step out and go there and have a look at what the other exhibitors are showing, and maybe there will be a connection not for today but for tomorrow. One last, we have a short time left. What will you do tomorrow? With that idea in mind, who will you visit firstly?
So have a look. We'll be on the show definitely tomorrow. No, we will exploit it further. We will work with groups like AM Energy, for example, actually to get the industrialization forward, to get the standardization forward. Because the idea of AM is basically, we want to establish it as a production method, and this will, let me say, increase the numbers, will increase the number of printers, the number of applications, will reduce the cost. We want to establish the technology, so this is the way we work.
Where will you go first tomorrow, under a personality view? Just not the professional, just for you. What will you look at the exhibition?
At the exhibition tomorrow, my schedule?
Yeah.
Well, basically trying to find as many vertical players, verticalized players, so I said in the medical field or in the industrial field, the one who are in contact with the users directly, because we can be sometimes far away as an OEM, and we have to be on the field to solve applications.
Yeah.
Okay. Thank you, guys. Thomas Batigne, CEO of Lynxter, Alexandre Schäfer, Business Development Management of J.A.M.E.S, und Udo Burggraf, Sales Manager EMEA of Additive Industries. Thank you very much for being with me and have a very successful exhibition. And I hope your dreams come true. And yeah, next days will be busy for you, I think.
Yeah.
Thank you very much.
For the opportunity.
Yeah, and thank you very much out there. Yeah, an applause for you three, for sure. Thank you very much for these insights. And after a short break here, we will have some highlights from the exhibition. We will have the next highlight here at the stage with this Discover 3D Printing seminar. So see you later.